So hey everyone, welcome back to my channel. My name is Tanuj. So in the last video we had solved all the LeetCode problems, or not all, the most popular LeetCode problems related to arrays, which are easy ones. Okay, so in this video we are going to solve the same, all the LeetCode easy problems, but in strings. All right, so strings will be the topic for this video, where we are going to solve the most popular LeetCode questions related to strings. Okay, and the probability of these questions appearing in an interview is about 80 to 90%. Okay, so if you're much familiarized with these LeetCode questions, you will be able to solve most of the questions that will be asking in interviews. Okay, so that's my motive behind creating this particular video. So I will be giving you an explanation about the problem and how exactly to solve this, including the brute force and the optimal method as well, and then giving you a clear-cut whiteboard explanation, and then we will be coding the problem. Okay, so if you find this video helpful and the upcoming DSA lectures also on this channel, please subscribe to this channel so that you get notified about any new upcoming videos. Okay, so let's get started by solving the very first problem on strings, that is valid palindrome, which is one of the most popular LeetCode questions which are asked in interviews. So here we are given the string where we are told to find out whether this is a valid palindrome or not. Okay, so there is one challenge over here. We need to exclude all the special characters that are included within the string. Okay, like this commas, this colon over here, and also the white spaces. So all of them we need to remove them and then check if this is a valid palindrome or not. Okay, so the very first way of solving this is by applying regular expression. Okay, so basically we want to filter out all those special characters within the string. So the regular expression would look something like this, where you write it inside a square brackets. Okay, so inside this we use a caret to start from to match the start line, and then we want to include all the characters that starts from A to Z, and also from capital A to Z, and also from 0 to 9. Okay, so only these are the characters that is a right candidate for the checking of valid palindrome. Okay, so we check for every character. So if it is a right candidate for checking if it is a palindrome, so if it matches this particular regular expression, then we pass that. Okay, so we convert the string. So we also want to check for all the characters, so we use a global flag. So by the way, we need to add 2 slashes over here for regular expression, and also we want to replace that by an empty string. So we can use the replace method to replace all of this with an empty string. Okay, so if we exclude all the white spaces, the commas and this colons, so it would look something like this, man. So this is the cleansed string, and here we just need to check from the last character to the first character, so if they are matching, and then we just first we set 2 pointers I and j over here, and just check if they are equal, and then we just, if they are the same, then we go to the next by incrementing I and decrementing j. Okay, and then again check the same if they are equal. As long as we find any character that is not equal, then we return false. Okay, so once we finish all the characters, finally if we do not find anything that are unequal, then we return true. Okay, so we just need to return a boolean value at the end of our program. So this is the solution for this problem, valid palindrome. So let me just repeat if it's not clear. So basically we are applying this regular expression which will clean our string by all the white spaces and the special characters. So only these are the valid candidates for the checking of valid palindrome. Okay, so we just replace all of that by an empty string, and then finally we have this cleansed string, and then we apply the palindrome checking by initializing 2 pointers and then checking if they are equal, and just keeping on decrementing as long as they intersect to each other. Okay, so we just return true if they if this is a valid palindrome. Okay, so let's see how can we code this. So let's start by creating a helper function which will help us filter all the alphanumeric values from our string. So let's create that function. I am going to call this can say filter alphanumeric. Okay, so this is going to take in the string itself, and here inside this we can just filter out all those that are not there. So we can use the replace method on strings. So first let's convert this to a lowercase. So return string dot to lowercase, okay, and then we can chain in another method called replace, and this is going to first take in the regex just as I explained. So we can just create another variable here we can call this non-alpha numeric, okay, and here we can just use the regex by setting this to 2 slashes, and inside that use square brackets and a caret to match the start of the line, and we can say A to Z and then from 0 to 9, okay, and then we need to do this for all the characters, so we can use a global flag and case insensitive, okay. So this is the regex, so we can just use this non-alpha numeric, and then we can pass in our string over here, basically the empty string. So if it is a non-alpha numeric, then it will just get replaced by an empty string, okay. So now let's continue from here. So we can first clean our string by passing it into this function. So we can call this cleansed string and set that to filter alpha numeric, so basically this function, and we can pass in our string over there. And after this we can set 2 pointers just as I explained by setting the pointer to the start until the end of the cleansed string. So let's say I equals 0 and j should be the cleansed string minus dot length minus 1, okay. So now we can just put a while loop while I is less than j, and we can just put in a condition here. If the cleansed string at the ith index, if that doesn't equal to the cleansed string at the jth index, so if that doesn't equal to at the jth index, so we just want to return false, okay. And then we go to the next iteration by incrementing I and decrementing j, okay. So finally if this while loop completes, so if there isn't any inequality between the two characters, then it is a valid palindrome, so we just return true, okay. So that's the solution for this problem. So basically we create a helper function to filter out all the non-alpha numeric characters, and then we get that cleansed string, and then we just place 2 pointers on the start and the end, and we just keep on decrementing one by one till it finds that there all the characters are equal, then we return true finally, okay. So let's run this, and that passes, okay. So let's submit, okay. So that looks good. So this is the solution for the problem valid palindrome. So we have just solved the very first problem on strings, easy. So now let's move on to the second problem. So this is a problem where we need to add in 2 binary numbers, okay. So we know that binary numbers are represented in the form of zeros and ones, and we just need to add them, okay. So if we add 1 and 1, so that would become 1 0, okay. So basically 1 is the carry and 1 is the sum itself, okay. So if you see that if we add 1 1 to 1, so it would become 0 0 and then 1, so it is not read as 100, so it is read as 1 0 0. So this is basically in the binary format, okay. So we just need to understand how can we solve this. So let us understand how to add 2 binary numbers, okay. So if I add 0 and 0, okay, so these are binary numbers and these are represented in the form of bits, okay, and these are not just numbers, okay. So if I just add them, it will become 0. So now again if I add 0 plus 1, the answer will be 1, okay. So there are 2 components when we add 2 bits, okay. Basically one is the carry and one is the sum itself. Over here the sum is 0 and the carry also is 0, okay. So if you are adding 0 plus 1, so the sum is 1 and still the carry is 0. So now if I add 1 and 1, so the binary representation of adding 2 binary numbers would become 1 0, okay. So here again there are 2 components, so the sum is this time 0 and the carry is 1, okay. So I can also write this over here, sum is equal to 0 but carry is 1, like this. And also if I add in 3 bits this time, so 1 plus 1 plus 1, so that sum would be 1 1, okay. And this is a binary representation, so this is not read as 11 or 10, so this is just 1 1, okay. So this is of base 2, so all the other numbers by default are base 10, that we usually deal with numbers, right. So they are by base 10 and this is base 2, basically representation of binary numbers, okay. So if I add 1 plus 1, it would become 1 0. So again if I add 1, it would become 1 and 1, okay. So here the sum is 0, the sum is 1 and then the carry is also 1. Okay, so by using this knowledge we need to solve the given problem. Okay, so what is the given problem? That is to add 1010 and 1011. Okay, so these are the two numbers that we need to add. So if I just manually add, so 0 plus 1 is 1, and then we do not have any carry, so we add 1 plus 1, so this time we have a carry. The sum is 0. Okay, so there again, please don't forget these two components, one is sum, one is carry. So here the sum is 0 but the carry is 1, so I can add the carry over here. So now I need to add in all the 3 bits, so 1 plus 0 plus 0, so the sum is 1 and then the carry is 0. Okay, so again now I add 1 plus 1, so here there is a carry but there are no more bits, so we just have carry and no more numbers over here, so we just add the carry at the last. Okay, so this is the number which we need to return at the end of our program. Okay, so this is all just we are doing it manually, so we just need to represent this in the form of code. So the question over here is, how do we translate this particular logic into JavaScript code? So let's understand that. So basically we use two pointers to solve this particular problem. So we set that two pointers to the last number within our two numbers. Okay, two binary digits. So we can set I over here and j over here. Okay, so I points to 0 and j points to 1 over here. Okay, so here we just need to just add these two numbers, and then we also have we initialize a carry variable and initially set to 0. So once we add these two numbers, you see that the sum is 1 and still the carry is 0, right? So we just need to update the carry whenever we find two bits that are the same. Okay, so when we add them we get a carry, right? And also we need to also check if the carry is 1, but still that would count, right? So 1 plus 1 plus 1, there would be sum is also 1, carry is also 1. So we need to keep in mind this particular logic when we are solving this. Okay, so I know this sounds a little bit confusing, so I'll just make it clear and show you in a tabular fashion. So basically I initialize two pointers to the last number, right, within the given two numbers. So I will just take them from a reverse order, so that would become 1 0 1 0, so that's the first number, and this is 1 0 1 and 1. Okay, so these are the two bits that are basically given within our problem. So and also we have something called as carry, right? So I can also initialize that carry over here. So let's say carry. Okay, and we don't know what will be the carry, so we'll just leave this column blank. And also we have something called as sum. Okay, so as I told you, these are the two components. So now we just need to calculate by adding two bits. Okay, so as I told you, this is the I pointer and this is the j pointer. Okay, so now I add 0 and 1, so the sum is 1 and then the carry is 0, as I told you. Okay, so there is a formula which we need to apply over here. So in order to solve this problem, we just need to take the modulo of the sum by 2, and then we just need to add them to the given results array. So we will be having a results array over here, and then we just keep on pushing the bits over here. Okay, so we can just say this bit, or we can call this a new bit. Okay, so this formula for this is sum percentage 2. Okay, so basically we are taking the modulo of that. So what is the sum over here? So that is 1. So what is the modulo when we do by 2? So that will become 1, right? So 1 divided by 2, basically the quotient is 0 and the remainder is 1. So the remainder itself we are taking into account. Okay, and we have another column over here, that is carry. So this will be the new carry. The formula for this is going to be sum divided by 2. And then we need to take the floor value of that. Okay, so we can just say floor, and then we need to calculate that. So 1 divided by 2 is 1 by 2, that is 0.5. if we take the floor value of that, so value of this is 0. Okay, so and we have a results array over here. Okay, so we just keep on adding elements to that array. So what is we just need to add the new bit, so that is 1, so we add that over here. Okay, so now we go to the second iteration. So now this becomes I and this becomes j. Okay, so for the second iteration. So I hope this is not confusing you. So now whatever the carry we had previously over here, which was 0 for the first iteration, we just need to carry that to the second iteration as well. Okay, so the carry here becomes 0. Okay, so initially it will be 0 for the first iteration, and then for second iteration will be the value of the previous one, that is 0. Okay, so now we just need to add these three numbers over here. So 1 plus 1 plus 0, so that would what will be the sum? So that will be 2. So here we are just adding the two numbers. So okay, but not in the binary form, but in the number form itself. So and now we just need to calculate the new bit. So some %2, that would become 1 over here, because sorry, this would become 0. So the remainder 2 divided by 2 is 0, and then the carry of this is going to be sum divided by 2. So that is 2 divided by 2 is 1. So the carry is 1 over here. Okay, so this is just like a formula which we want to represent in the form of our code, so that it will be easier for us to code and also for us to understand. Okay, so then we shift the carry from the previous iteration to the current one, so here, and then we increment or decrement I or decrement j. So now these two values are 0. So 0 plus 0 plus 1. So the sum would become 1. And now we take the modulo of this with 2. So 1% 2, the remainder is 1, right? And then we check for the carry. So 1 divided by 2 is 0.5. We take the floor value of that. So that would become 0. Okay. So this carry gets continue ahead. So 1 plus 1 plus 0, the sum is 2. Okay, I hope you get the idea right now. So you can just pause the video and just analyze for a moment if you want. So 2% 2, that is taking the modulo, so that would become 0, and then divided by 2, so the carry is 1. Okay, so I forgot to add this new bits to the result array, so which I actually forgot. So 0 1 0 1 0. Alright, so now we have ended the all the bits, okay, within our current iteration. So this we had to increment over here as well. Okay, so once we have completed our iteration, so we just need to check if we still have a carry or not within the end. Okay, so if there is a carry, then we add that carry to the last element. Okay, and so this is the result array, but this is not the final solution. Okay, so since we are looping across, we are iterating from the last element, right? But we are adding on elements from the first element of the array. So what we need to do is we just need to reverse this array and then join it in the form of a string. Okay, so if we reverse this, this is like a palindrome. It's still same, that's 0 1 0 1 0 1. So we just need to convert this in the form of string and return this as the solution. Okay, so I hope you got to know the logic of this. I hope it wasn't too confusing and I made it a little bit clear. Let us see how can we solve this by code. So let's initialize the two pointers to point at the last element of the string. So let's set I equals to a dot length minus 1, so that would point at the last element of a, and we just need to do the same for b as well. Okay, so we can call this j and set this to b. Okay, so now we just need to run a while loop. Okay, so the condition over here is we just need to check if I and j both are in range. So we can just set I is greater than or equal to 0 and also j greater than or equal to 0. So first we need to grab the two bits for the particular I and j values. So let's set bit a and set that equal to a of the particular value, that is I. So this is in the form of a string, right? So we need to convert this to a number. So we can just use parse int, and we need to do the same for b as well. Okay, so const bit b and parse b at the value j. Okay, so we got bit a and bit b. So as I told you, we just need to add them along with the carry. Okay, so let's also initialize the carry and set that to 0. So we can use let carry equal to 0, and also let's initialize the results array. So or the just the result. Alright, so now we just need to add all these three, so that is bit a, bit b and the carry. So let's store that in a sum bit a. Okay, so now we just need to push the sum to this results array. Okay, so just as I told you, so result dot push sum, and we need to modulo this by 2 as I told you. So modulo 2, so this will store the reminders, so that will be in the form of a bit, so between 0 and 1. So and also we need to update the carry variable. So how do we do this? So as I told you, we just need to floor the value by dividing the sum by 2. Okay, so let's use maths.floor and then pass in sum divided by 2. Okay, so now finally we just need to go to the next iteration. Okay, so we just do that by decrementing the 2 pointers, so I minus minus and j minus minus. Okay, so finally once we come out of this while loop, we just return the result array. Okay, result. Okay, and as I told you, the result array is in the form of we are just adding the elements one by one. Okay, so but we are starting from the last index over here. Okay, so we just need to reverse this array and then convert this back to a string. Okay, so if we see in the problem statement, this is in the form of a string, right? So we just you can use the reverse built-in method on strings, and then we join them by an empty string over here. Okay, so you see that we have another problem over here. So we are not countering for the case where the carry is 1. So basically, if I and j are out of range but still we have a carry, so we just want to add that carry to this results array. Okay, so for that we can put in another OR check over here and set carry, basically a truthy value, basically if the carry value is 1, and now we just need to check if bit a and bit b are still in range or out of range. So for that we check if I is greater than or equal to 0, then we do this. Basically if they are in range, so if they are not in range, then we just put them to 0. Okay, so we just need to do the same for j as well. So basically if they are out of range, the bit a and bit b will be 0, and then we add that to the carry, and then finally join them to the results array, so by pushing this. Okay, so let's run this, and that passes, and let's see our performance. And yeah, so since we are creating like too many variables over here, so our space complexity has been decreased, and also time complexity is kind of okay. So there might be a better solution for this, but I guess we can just go with this solution, which is easy to understand and as well as easy to implement as well. Okay, so let's go to the next problem. So this is a problem where we need to calculate the first unique character within a given string. Okay, so you will be given with a string and we need to find the first character that is unique. Okay, so there could be many elements that are unique. You see that E is not unique because it's been repeated 2 times over here, and T is unique, L is unique. So you see that L is first unique. Okay, so we need to return L. Alright, so I hope you got the point. So even T is unique, but in the that is second unique character, so the first unique is L, so we need to return L at the end of the program. Sorry, we need to return the index of L within our program. You see that the index of L is 0, so we need to return 0. Okay, so if you see the second example, the letter L is being repeated 2 times, and O is also repeated over here, and then V is the first unique character, so we need to return the index, that is 2. Okay, because V is at the second index. So how can we solve this? So let us consider this LeetCode string as our example, which was also given in our LeetCode problem. So that is LeetCode. Okay, so what is the brute force way of solving this? Okay, so if we want to check what is the first unique element, so what we would do is we basically use nested for loops. Okay, where we check the first element and then the comparison element. So we check if those 2 elements are same or no. So we can have a flag like, let's say, unique, and set this initially to true. Okay, and then whenever we find an element which is the same, then we make the unique to false. Okay, and then move to the next iteration. So you see that within the first iteration itself, L is unique, right? So you see that L, there's no other L over here, so the comparison elements doesn't match, so we return the letter L itself over there. Okay, so as you know that we are creating nested for loops, and the time complexity of this is going to be O of n square, and yeah, so we just need to avoid any kind of program that has nested for loops. So we just need to come up with a better solution rather than comparing two elements and just keep on doing the same over here. Okay, so this would take an operation of like 8 characters are there, right? So we just need to do 64 comparisons, so which is terrible in terms of performance. So we just need to solve this in a smarter and a very optimal way. So the solution for this is to calculate the frequency of every letter within the given string over here. Okay, so we just create a map data structure. As I told you, we already solved this one problem using maps in the previous LeetCode problem. So basically maps is used to store any kind of key value pair, any kind of data structure if you want, so as the key or value. So we create a map like counting the frequency of this, so how many times L is being occurred, so that is once, and then we actually keep a pointer over here and then keep looping across. So we just add that particular key to this. Okay, so first we check if the key exists, then we increment that like this. So if that doesn't exist, then we add a key value pair, so that is E, and then count the frequency of that, then it is 1. And then for this third iteration, so that would become 1 plus 1, it would become 2. And then if T doesn't exist, we create one key and we add 1. Okay, so I hope you get the point how we add the frequencies. So this will all be in order, right? So all of this will be in order. So we just need to check which is the first element, first character that is been repeated only once. Okay, so if it is 2 means there is a duplicate, which means that character is not unique. So we start from the first, we see that L is over here, so that is occurring only once, so we return L. Okay, so let's say for example L doesn't exist. Okay, so I can just use this. So we have E, which is occurring 2 times. So you see that E is not unique because occurring 2 times, and then we go to the next element, that is T, and you see that the frequency is 1, so we return T. Okay, so I have given you all the possible cases over here. So I hope you got the point how to solve this particular problem, first unique character. So what is the time complexity involved in this operation? That is O of n, since we are looping across each and every character within the string, so the time is O of n. So what is the space complexity? That is also O of n. Okay, by worst case all the elements would be in this map, right? So all the elements would be unique, so the worst case is O of n again. Okay, so in the previous, the brute force way which I told you, right, by creating nested for loops, there we just had to just use this one flag over here called unique true. Okay, so we are not depending on the number of characters, so we are just using by comparison element. So over there the space complexity is just O of 1. Okay, but still the time complexity is very is worst, so that is n square, which we need to avoid. So yeah, so in order to improve the time complexity, we just need to use some amount of space. Okay, so in order to counter this particular problem or to solve this problem. Okay, so I hope you got to know how to solve this problem, first unique character. Let's see how can we solve this by code. So let us first create a map to hold the frequency of every character within the string. So let's set count equal to new map. So basically map is a built-in constructor in JavaScript. So once we do that, we just loop across every character. So let's run a for, and we are going to use a for of loop char of s. So since these are strings, we can use a for of loop, and then we just set the frequency of every character. Okay, so we can just do count dot set. Okay, so set is a method which we can use on maps basically. So we need to set the key value pairs. Okay, so this will take in 2 arguments. So we set the char itself as the key, and the value of that is going to be the frequency of that. So initially the frequency of that will be 0 or null, so we just need to check for that. So we can just do count dot get and pass in char. So basically get is a method on maps which we can find the key and we get the value, and if that exists then we use that, if not we initialize that to 0, and then whatever is there then we increment that by 1. Okay, so initially it will be 0, so the second time it will be 1 maybe, so that will get the by this method, so 1, 2 or 3, and then we finally add 1. Okay, so once that's done, we now need to return the first unique character. So we loop across whatever we have within our count. Okay, so we run a for let I equals 0, I less than string dot length, because that's the maximum limit, the length of that. So we increment I, and inside this we just need to check by the index that we have. So we can do count dot get the string at I. Okay, so if that is equal to 1, so basically if it occurs only once, and which means it's unique, then we just return I. Okay, so basically we need to return the index, right? So we return the index itself, that is I. So if we do not find any unique character, we just return -1. Okay, so since over here is given, so if we do not find any unique index, we return -1. That's what we are doing here. Okay, so let's run this. Sorry, this should come outside like this, and let's rerun, and that passes. Okay, so if I submit this, and we are getting good time and space complexity over here. Okay, so this is the solution for this problem, that is finding first unique character in a string. So now let's move to the next problem. So let's first set the result to an empty string. Okay, so now we can run a for loop to iterate across every character within the given string. So let I equals 0, I less than string dot length. So inside this for loop, we need to get the character code. So we can just check for the char code and set that equal to string dot char code at. So this is the method we can apply on strings to get the character code at the particular letter. So we can pass in the char code at. I wish I would use VS Code, which would give us some suggestions. So this editor doesn't even give me suggestions, so that way I'm a little slow in typing. So anyways, so let's first check if the character code is within the range. If that is greater than or equal to 65, so we are checking if this is a capital letter, and we need to check another range for this, is less than or equal to 90, so that is the last letter, that is capital C. So that is why it is O of 1. Okay, so this is a fixed size map. So let's see how can we code this. So if this is a capital letter, then we convert that to a small letter. So as I told you, we need to add 32 to the character code. Okay, so we just append the result string to this particular value. So we use the string constructor, and we have a method called from char code, and here we just need to pass in our char code by adding 32. Okay, so this will add the character code by adding 32, which is a lowercase, and then adds it to the result. Okay, so if now we just need to check if that is already a lowercase, then we just add that to the result string. So result plus equals, and then the string at ith index. Finally we return the result. Okay, my bad, plus equals, and that passes. So let's see. So best in time complexity, but not the best in space, since we are creating this extra variable over here. Okay, so this is the solution for this problem, that is to lowercase. And to talk about the time complexity and space complexity, so that is O of n, right? So we might have the result string to have the entire string itself. Okay, so obviously the entire string itself will be the result, and the time complexity is again O of n, since we have to loop across all the elements within the array. Okay, so the time and space complexity is O of n. So let's now move to the next problem. So this is a problem called repeated substring pattern. Okay, so we will be given a string, and we need to check if it can be constructed by taking a substring of it and appending it multiple copies of the substring together. Okay, so we see that this is a string, and we see that if I consider this string AB, and if I create another copy of that AB, so you see that I can form this given string AB. Okay, so at the end of the program we return true over here. Okay, whereas we see in this example, this is called ABA. Okay, so any substring, so I can't consider A also, I can't consider B also, because if I create multiple copies of this, I cannot construct the original string by creating multiple copies of that. Okay, so I hope you get the point. And you see that this is a string which is given ABC, which is repeated 4 times. So if I just consider this ABC and then repeat repeated 4 times, so I can obtain the string over here. Okay, so that's what this problem statement states. So let's see how can we solve this. So AB is a substring, which if I just make a copy of it again, AB, I will be able to obtain this string. So we just need to check if this could be formed by taking a substring of it and return true or false value. So if it can be created, then we return true, else we return false. Okay, so I hope you got the point. So what we could do is we can iterate this particular string character by character till the half of the string, and then we need to check if it is divisible by the particular length. Okay, so you see at first iteration, if the length is 1, right? So if that is divisible by that, then we skip that and we go to the second iteration. So we put I over here. So we are just looping across half the string, so we don't have to do it fully, because if we just repeat the multiple copies of half the string, then we get the entire string itself, right? So that's why we are doing only till here. Okay, so now we just need to check I. So I is 2, right? So we just need to divide that by 4. So 4 is the length of the string, so we need to do 4 divided by 2, so that is divisible, right? So then we check this particular string. So we have AB, right? So we create multiple copies of this. Okay, so since this condition is true, we create multiple copies of this. So we check AB and AB again. So this is a copy, right? So this matches this given string over here. Okay, so that we can return true over here. Okay, so if let's say there is another AB over here, so we again append another copy of this to this. Okay, and then again we check if this still matches the string over here. Okay, so we can just calculate the length of the string, and based on that we can create multiple copies and check if this could be formed by this particular substring over here. Let's take another example over here, like let's say ABC and ABC. Now I take the half of this, so ABC. So now I just start the iteration. So the total length is 6, right? So the iterative value is 1. So we check 6 by 1 if that is divisible, and divide this by 1. So it is 6. Yes, it is divisible. So we create multiple copies of A. Okay, so we see that this doesn't form the string. Okay, so this iteration fails. So now we go to the second iteration. Now the value of I is 2, so we update this to 2. Okay, so 6 divided by 2 is 3. It is divisible. So now we create multiple copies of this, so it becomes AB, AB and AB. So does this match the given strings? No, right? So again we move I to the last one. So this will be the last iteration. So now we take the division of this. So 6 divided by 3 is 2. Yes, it is divisible. So this is 2, and now we create multiple copies of this. So this gets updated to ABC, ABC. So now you see that this is the given string over here. Okay, so once we find that these two are equal, then we return true. So I hope this made sense. So here the time complexity is O of n square. Again, this is not the right solution, because you know why? Because we are slicing the substring and then we are repeating, and we are just making the comparisons, right, for every possible length. So that is why we are making these many comparisons. So this is the time complexity, and the space complexity is just O of 1, because we might have a substring. Okay, the worst case could be the entire string itself. Okay, so is there a better solution? Yes, there is, and let me show you the trick which you can just solve this by just at a time complexity of O of n. Okay, so we just gonna solve this. So here's the trick. What I can do here is I can just repeat this string 2 times. Okay, so I can just add the same string like into 2. So this becomes AB, 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 AB. So I am just multiplying that by, so I am just creating another copy in the same string. So now I just need to remove the first element and the last element. Okay, so now I just need to check is this original string contains inside the string. Okay, so you see that AB, AB is over here. So then we return true. Okay, cool, right? Let's see another example like the previous one, ABC, ABC. So now I just create multiple copies of this, ABC, 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 and now I remove the first and the last one. Now I check if this is consisting inside our substring. You see that it does consist, so then we return true. So let's say this example over here, I create multiple copies of this, and now I slice the first and the last element over here and check if this consists within this. So you see that nowhere it exists, right? So ABA is not consisting inside this modified string, so here we return false. Okay, so I hope you got it. So what is the best thing about this? We are reducing the time complexity to just O of n. Okay, so we are just doing the substring check just once. Okay, and yeah, so the worst case is that, and space complexity is also just O of n. Okay, so that will become O of n plus n, so that would still constitute to O of n because we are doubling the string. So this is the time and space. So let's see how can we solve this. So let's now double the string by calling this double, and we can just do s plus s. Now we can slice off the first and the last element within this doubled string. So let's call this sliced and set this to doubled dot slice. So let's call this doubled and slice. So we slice the first character and then the last one. So we check the length of this doubled and then subtract 1 from that. Okay, and calculating the length, so -1, and now we just check if this given string includes in the sliced string. So we just return sliced dot includes. So this will return a true or false value if it includes within another string. So whether a substring includes in a string. So we can just pass in s over here, and now we can just check if our answer is right. Let's run this, and that passes. So we are getting good time and space complexities. So let's move on to the next problem. So this is a problem called Roman to integer, where you will be given a Roman value and we need to convert that to its integer equivalent. So the Roman value will be in the form of a string and we need to convert that to a number, okay, to its equivalent integer. So for example, they have given a set of symbols and its equivalent value. So I is 1, V is 5, and it goes all the way up to M. Okay, so we will be given a string somewhat like this and we need to convert this to a number. So how do we solve this? So to solve this problem, we need to first create a map over here. Okay, so map which holds the particular value of the particular Roman number. Okay, so the value of I is 1. Okay, and then V is 5, as you know, it's also given in the problem statement. So we just need to create an JavaScript object over here and then access for which character, that is I over here, and what is the value of that. Okay, so X is 10, L is 50, and then we have C, which is 100, we have D, value of that is 500, and finally we have M, the value of that is 1000. So I hope you can see this. I can reduce this a little. So once we have created this map over here, let me just consider a simple example, that is IV. We all know that the value of this is 4. Okay, so how do we calculate this? So the first step which we need to consider over here is whatever the value which we are starting from here, that is I, right? We see the next character of that, so that is V, and we need to check if V, the second character, is greater than the first character. Okay, so V is 5 and I is 1. Yes, it is greater. So in that case, we just need to subtract 5 and 1. Okay, so 5 minus 1, so that would become 4, and 4 is the answer. Okay, so since we have only 2 characters within our string, so we need to return this is the answer. Okay, so if I just take another complex example, so this is another fairly complex example which we need to calculate the integer for this Roman value. So the value of M, as I told over here within our map, we need to check it's 1000, and what is the immediate next value of that, that is C. So the value of that is 100, right? So as I told you, the next value, if it is less than the previous value, then we need to subtract the next value from the previous value, but here it's not the case. So here M is 1000, C is 100, so we just need to add them. So we will be having a running total, okay, which is a variable which you can initially set to 0. Okay, and now we see that the next value is not less than the previous value, then we add the previous value to the current total. Okay, so 0 plus 1000 is 1000. all right, and then we move to the next one, that is C, and then we need to check the value of the immediate next character M. Yes, M is greater than C, so 1000 is greater than 100. So what we now need to do is 1000 minus 100, so that is 900. So we need to add 900. Okay, so now we just need to skip these 2 iterations. So we have counted that, and then we go to the next one after M. Okay, since we have already calculated for M as well, so we see that X, the value of X is 10, right? So what is the immediate next value of that? That is 100. So 100 is greater than 10. So again we need to subtract 100 minus 10, that is 90. So I add 90, then I go to the next after C. Okay, so we need to skip this since we have already calculated that. So the value of I is 1, and what is the immediate next? So that is 5. So 5 minus 1 is 4. So we just add 4. So if I calculate the total, it would be 1994. So this is the solution which we need to return at the end of our problem. Okay, so I hope this is clear. Let me just repeat. First thing is we need to create a map for this, which will store the Roman value to the integer value of that. So once we do that, we just check the immediate next value of that and check that if it is greater than the previous value, then we subtract that and add that to the total. If not, we just add the value directly to here. Okay, just as we did for MCM over here. Okay, so we just need to finally add all the total and then return this as the answer. Okay, so what is the time complexity involved? Since we are iterating every single character within the given string, so the time complexity is O of n, and also the space complexity, since we are creating this map over here. Okay, so and yeah, so this space complexity is not O of n, but it's just O of 1, since it is not dependent on the number of characters that we have within the string, right? So this will be of fixed length. So let's start by creating a map, so which is basically an object which stores all of these values, the Roman numeric values to its value. So I'm just going to call this Roman, let's say Roman map, and this is going to contain the key value pairs of the Roman value, and the value of that is going to be whatever is there. Okay, the actual value. So let's do the same for all the others. So next is going to be, which is the value 5, and then we have x, which is 10, and then we have L, which is 50, and then we have C, which is 100, and then we have D, which is 500, and finally we have M, which is 1000. All right, so once we have created this object map, so we just need to create a running total, right? So let's start by initializing a variable called, let's say, total, and set that initially to 0. So now we are just going to run a for loop for every character that we have within the string that is passed in. So let's set the pointer I and set that to 0, and I is less than the string dot length, and then incrementing I. So now we just want to get the current value of the iteration, so basically from the Roman map. So we can just call this current and set that equal to Roman map, and at the particular key, right? So whatever the key that for the current iteration is, so we can use square brackets and s at the ith index. Sorry, this should be equals, and sorry, I, and then we need to get the next value. So we can just duplicate this and say I plus 1. So basically we just want to compare the next value and the current value, so which one is greater, and based on that we are going to do something. Okay, so let's check if next is greater than the current. So as I told you, we just need to subtract the current value from the total. Okay, so we can just say total minus equals current. Okay, so if that's not the case, then we just want to add the current value. So total plus equals current. Okay, so finally we return the total. Okay, so I hope this is clear. We create the map, so we check which one is greater, the next value of the current value. Based on that, we increment or decrement the total from the current value. Okay, so very simple. Let's run this code, and that passes. Okay, so let's submit, and yeah, that looks good. So this is the solution for the problem Roman to integer. So let's now move ahead to the next problem. So this is a problem called Excel sheet column title. Basically we will be given a number and we need to find the equivalent column number within an Excel sheet. So if you see in an Excel sheet, So we'll be having a lot of columns, right? So for every column number will be assigned a letter over there. So once it exceeds all the 26 alphabets, so it starts from AA, AB, AC, like that. Okay, based on the column number, so let's say 28, so it is passing 26 letters, so it is passing the Z. So again it will start from AA, so again then AB, so AB is the answer. Okay, so for the column number 28 and so on, we just need to calculate. So what for whatever the number or the column number that is passed in. Okay, so this is the problem. Let's see how can we solve this. So let us take 28 as the number which we want to find the column title. Okay, so the first step what we need to now do is we need to calculate the modulo of 28 with 26. Why 26? Because there are 26 letters in English alphabets. So we need to check if it is in range, so if it is within 26 characters or not. That means that we have a letter and we need to append that to the result string. So we'll just be having a string over here and we just need to keep on appending it. So 28 is greater than 26, so what we just do is we take the modulo of that and the value of that will be 2. Okay, and with this 2 we need to get the character code of this. So what exactly is the character? Okay, so if I add 65, where 65 is the character code for the letter capital A. Okay, so if we add plus 2, it would become 65 plus 2, it would become 67, and that would become C. Okay, so C is not the right one because we need to make it 0 based index. Okay, so for that we just need to subtract 1 within our column number itself. So if it is 28, we need to subtract 1, so that would become 27. So 27, so if you take the modulo of that with 26, so the value would come down to just 1. Okay, so 1 you add to 65, so the value would become 66 and the character code at 66 is B. Alright, so we add this B to this string. Okay, so we want to add it in the reverse order. Okay, and then what we now need to do is update the column number. So now the column number is 27, so we need to divide that by 26. So 27 divided by 26, so we just need to take the floor value of that. So since we have already calculated for the remainder, so that would be B. So now the column number gets updated to 1 over here, and then we just need to update the column number over here as well, so that would become 1. And since we need to convert this to 0 based, so we need to also subtract 1, so overall this would come to 0. So 0 modulo 26 is like 0 itself, so we need to put a check over there, and we just need to so this is 0 plus 65 and the character code of that is A. Okay, so so this is for the previous value, and now we add A to before this B over here. Okay, so this is the solution. So once we do not have any other column numbers, so if we are out of range in column numbers, so less than 0, so then we stop our iteration from there on and then return whatever we have within the string over here. Okay, so clearly we see that for the 28 column number, the Excel sheet column title would be AB. Okay, so for 26 it is Z, and then it will continue AA, that is for 27, and then AB is 28. Okay, so I hope you understood this particular logic. So I'll just repeat once again. So first we just need to take the modulo of this number. So first it is 28, so by the way you need to convert that first to 0 base, so we need to subtract 1, so that would become 27, and take the modulo of that with 26, so this would become 1. And then we just need to add 65 because that is the character code of A, and then we calculate that what is the character code, so that would become B, and then push that to the last to the string, and then we divide this we divide the column number, that is 27, with the 26, and then whatever the column number we have, so we need to update that. Okay, as long as it is not going less than 0. So if it going less than 0, then we need to stop over there and then return whatever we have within our string. Okay, so I hope this is clear. Let's see how can we code this. So let's start by initializing the result string to an empty string. Okay, so result, and set that to an empty string. So now we can just put a while loop, so we can set a condition here. While the column number is in range, basically it should be greater than 0, so we do not want negative column numbers, so we can just say the column number, if that is equal to that is greater than 0, then we just want to, as I told you, we just need to decrement 1 to make it 0 based column numbers, right? So we can decrement the column number by 1. All right, or we can do minus minus, and here we can just calculate the remainder by modulo that by 26. So let's store this in a remainder, and here we can set the column number and take the modulo to that of 26. The next step is to calculate the character for that, so by adding 65. So we can just set that to a char, and we can say the string dot from char code, and we can just pass in the remainder and add in 65. Okay, once that's done, we can just append that to the result string. So as I told you, we need to go from the reverse order. So first comes the char and then we add the result. Okay, so now we just update the column number. So column number, and we can just set the floor value to that, okay, by dividing that by 26. So we can just say math.floor and column number divided by 26. Okay, so that's it. So we just have 5 steps. First is decrementing the column number, calculating the remainder, and finding out what is the character code of it by adding 65, and then appending that to the result string in the reverse order, and then finally we update the column number by calculating the floor value of the column number by dividing that by 26. So let's return result. Okay, so let's run. That passes. Let's see the submission. Okay, so this is the solution for the problem, that is what is that, Excel sheet column title. So now let's move ahead. So this is the problem called detect capital. So we'll be given a string somewhat like this, and we need to check in all possible ways if this is actually a capital letter in the right sense. Okay, so basically if there are 3 conditions that we need to abide to, so they are given over here. All letters in this words are capital, like for example USA, and all the letters in this words are not even a single letter which is capital, so for example this LeetCode, and only the first character in this word is a capital, Google. So if any of these 3 condition is passing, then we just return true, just as we see over here. And if any one of that is false, like for example this flag where the last letter and the first letter both are capitals, then we return false. Okay, basically this problem is trying to state that there should not be any misuse of capital letters within a string. Okay, so let's see how can we solve this. So there are basically 3 ways of solving this particular problem. One is by using regular expressions. Okay, so you know about regular expressions, right? So we just start from a forward slash and end with a forward slash, and then we write our expression over there. So the expression looks something like this. So if you want to check if all the letters are capital, so we just write something like inside we just put a caret symbol over here, indicating that it has to match the whole line, so the start of the line basically, and we put a $ at the end basically to match the end of the line. So basically all the characters within our given string, and we just need to put in a square brackets over here and say capital A to capital Z. So this will match all the letters from capital A to capital Z, and we need to put a plus over here, indicating that it has to match all the characters within our regular expression. Okay, so if you know about regular expression, this would make sense. Otherwise this is a little bit difficult to understand. So I would also come up with another solution where without any regular expression you can also solve it. So this is the first check. Okay, so this is to check if all the letters are capital, for example USA. Okay, so the second regular expression is we need to again start with 2 slashes and again do the same. For now it is lowercase letters. Okay, so this will match all the lowercase letters, like let's say LeetCode. Okay, so this would also validate, and then we just have a method over here basically to check if this is matching this particular expression, that is .test. Okay, for this regular expression over here, and then pass in our string over here. And finally, to check the first character if it is capital and the rest should be lowercase, so for example we can just consider Google. Okay, so which was given in the example as well. So over here it's slightly complex, so we just need to match the first character, and the rest of that should be lowercase. Okay, so for the first character we just say A to Z, so this should be a capital, and for the rest of the characters it should be from small a to Z, like this. Okay, and then we just need to add a star symbol over here, indicating that the first character should be from capital A to capital Z, but from the subsequent characters it has to match this particular expression over here from small a to small z. So basically from OOGLE, that has to be small characters. Okay, so and then put a $sign over here to match the end of the string, and yeah, so this is the regular expression for the first letter to be capital and rest smaller case. So we put an OR operator. Okay, so basically if any one of these conditions pass, then we return true, else we return false. Okay, so let's see how can we code this. So let us start by constructing the regex for the first condition. So we can just directly return from this like this, and we can use // for a regex. So in between that we can use a caret to start from the start of the line, and we can use square brackets to the condition that we want to apply. So that is from A to Z, so basically all the letters, and then we add a plus to match every single letter from the string, and finally a $sign to match till the end of the string. Okay, and here we can just, as I told, use the test function and then pass in the word. Okay, so this will return a true or false value, and yeah, so let's do the same for the other two conditions as well. So we can just chain using the OR operator and use another regex and do the same thing. First is the caret and then the $symbol to match the start and the end of the line. So in between the square brackets we can just do the same for the small letters, so that is A to Z, and add a plus over there, and .test, pass in word, and then pass in another pipe over here, basically OR operator, and we just need to do the same for the first letter. So / caret, and then the first, to check the if only the first letter is capital, we can say A to Z, another pair of square braces, and to check if all the other remaining characters are small letters, and we use a star for that. Okay, and then finally ending that up by a $symbol and .test, pass in the word. Okay, so let's test this. Okay, that passes, and yeah, so basically we can also use the inbuilt functions which are in JavaScript to basically to convert that whole word to a lowercase, and then testing the same with the original word that was passed in. So usually interviewers would not like to see you do that. Basically you want to bring in your own implementation, just as I did over here. Okay, so yeah, this is the solution for the problem, that is detect capital. Now let's move ahead. So this is a problem called length of the last word. Okay, so we need to calculate what is the last word within the given string. Okay, and then calculate the length of that. Okay, you see that the length of this word letter is, it contains 5 letters, right? So we need to return 5 over here. Okay, so that's not the case. We also need to counter the white spaces as well, so we do not have to include white spaces. So you see that a word is a maximal substring consisting of non-white space characters only. So you see that within this example we have 2 white spaces over here, so we don't have to include them. So we just need to return the length of this last word over here, only the word and not the space. So what we can do is we can set a pointer at the last element within the string, and then we just need to check as long as there is a given character. You see that from here there is a white space, here is a white space, and then we found a character. Okay, so that's when we start the count. Okay, by using a reverse for loop. So we just go till here and then check the white spaces, and then from here onwards we start the iteration, we start the count over here. Okay, so I'll just code this and just tell you how does it make sense. And here you see that there's no white spaces, so we start counting directly from the last word. So we just need to check if that current letter is a word or a blank space. Okay, so let's create a variable here to keep a track of the length. So let's call this length. Also let's initialize the pointer and set this equal to the string dot length -1, so basically to the last character. And now we just create a while loop. So while we say that the current value of the iteration, we check that if that is a white space or no. So we just want to ignore that. So we check if I is greater than or equal to 0 and the value of I in the string is an empty string. Okay, so basically it's a white space. Then we just want to do this. Okay, so we are checking if the I is in range, and if this is a white space, then we just want to decrement I. Okay, so since we are starting from the last, so we decrement 1, and yeah, so once we found there is a character, then we just put another while loop over here. So while I is again greater than 0 or equal to, and then we check if s dot I, this time it is not equal to a white space, like this, and then we just want to increment the length of this. Okay, so length plus plus, and then we decrement I. Okay, so that's it, very simple. And finally we return the length. Okay, so very simple. Let's check. So that passes. Okay, so if I submit this, and yeah, that looks good. Okay, so basically you can also use the trim function and then trim all the white spaces and just grab the last element from the string and then count the number of letters in it. But that's not ideally the interviewers would expect you to do. So it has to be manual and technical, so basically to test your logic skills. Okay, so the expected answer that you have to use using somewhat like this. Okay, so that's why I didn't go with that, and this is the right approach. So now let's move on to the next problem. So this is a problem called remove all adjacent duplicates in a string. Okay, so you'll be given a string and we need to check what are the adjacent duplicate characters that we have within the string. So what do I mean by that? So we see that this is a string over here, and we see that B and B, so they both are adjacent. So we need to eliminate these two characters. Okay, so if I eliminate this, we'll be having A, C, A. So again you see that A and A are adjacent, so we need to eliminate that as well. So finally we'll be left with C and A, and that's what we need to return over here. Okay, so you see that even in this example, X and X both are adjacent, so we eliminate that. Again we have Z and Z, they both are now adjacent, then we eliminate that as well. So finally we'll be left with A and Y, so that's what we return over here. So if you are not understood, let me just explain. So in this problem, what we can do is we can use a stack data structure to solve this. Okay, so I can just create a stack over here and initialize this to an empty array. So we can just keep on adding elements as long as they are not repeating within the stack. Okay, so you see that we add the element A first. Okay, and then we add the element B. So we add one by one unless we find that the next character, okay, the B, okay, so if it is there within the last element within our stack. Okay, so you see that B exists in our stack, so we just pop this element off the stack. Okay, and then move to A. So again you see that A also exists within the stack, so we also pop A off the stack, and then we add C over here, and then we add A. Finally we return the stack itself. Okay, so I hope that's clear. Let's see another example. So again we, in this example, have just taken another string over here. So what I just told is we keep adding elements to the stack. So we add A, and then we check the next one, Z, if that is the last element within our stack. So if it is not in the stack, then we add that Z over here, and then move to X. So X doesn't appear in the last element within our stack, so we add that as well. So now you see that the next X, so it is the last element within our stack, right? So we pop that element of the stack, and we don't add this as well. Okay, so then we go to Z over here, and you see that Z is also now the last element within our stack. So with that we just pop that off as well, and then we see Y. So Y is not the last element within our stack, so we add Y over here, and then we return A and Y as a solution. Okay, so A and Y are the they are the only characters that are having no adjacent duplicates. Okay, so that's why we need to return this. And yeah, so the time complexity here is O of n, since we are checking every character within the string, and also the space complexity is O of n, since we can have the stack worst case all the strings within the given letters. Okay, so let's try to code this. So let's initialize a stack and set it to an empty array. So we can now loop across all the characters we have from the string. So let I equals 0, I less than string dot length, Okay, so now we just check if that element exists within the last element within a stack. Okay, so first we check if the stack is at least has one element, so stack dot length is greater than 0, and we just check the last element. So we don't pop the element, okay, so we only check the last one. So popping will actually remove the element, so we check from the stack and passing the last element as the index within a stack. So stack dot length -1, and if that equals to the character, so we can call this character basically instead of I, or we can use a for of loop. So let char of s, and then we check for the character. If that is true, then we pop the element from the stack. Okay, if that's not the case, then we just push the element to the stack. Okay, so now we finally return if the stack is whatever the elements are there, so we just need to join them back to an string. Okay, so let's return the stack dot join and then join with by a string. Okay, so let's run. So that passes, and yeah, that looks good. Okay, so this is the solution for the problem remove duplicates. So now let's move on to the next problem. So this is the problem called is subsequence. So you will be given two strings over here, and we need to find if the string 1 is a subsequence that is present in string 2. So they have given in the statement that given two strings, return true if s is a subsequence of t, or false otherwise. Okay, so let's say this is the string that you have ABC. So we see that in the string T, so we have A, B and C, so they are all in sequence. Okay, so that is why we need to return true. So if they are not in sequence, so for example this example over here, A, X and C, so we don't even have X over here, even though if there is X, so they should be in the right order. So that is why they are not in sequence and we need to return false. Let's now understand how do we solve this. So here I have considered two strings that are given, that is S and T. So we need to check if this is a subsequence. So we see that A is over here, and then B and then C. So this is all happening in a sequence. It doesn't matter which character is there in between, how many ever characters can be in between. So this should be in sequence. Okay, so if I have C here and B over here, so that would not be in sequence, right? So it should be A, B and C and not A, C and B, right? So this is the challenge. So to solve this, we can use the two-pointer approach. So let's say I consider I to be at the start index of the S string. So I select I over here, and I can place J over here at the T string. So once we see that I and J both are equal, then we just increment I. Okay, so now if I and J are not equal, then we increment J. Alright, so again they are not equal, so again we increment J. Now they are equal, I and J are equal, so I increment I. Okay, so I and J are not equal, so I increment J here. Okay, so now I and J, you see that both are not equal, so I increment J over here. Again they are not equal, so again I increment. So now they are equal, so I increment I. So now I is pointing to undefined. Okay, so and undefined is not equal to which is C, so again we increment J. So we need to keep doing this as long as J is also out of range. Okay, so we need to put a while loop as long as J is in range with the number of characters that we have within the T string. So once it's done, we need to finally calculate the value of I. So I is at the fourth index, so the third index, 0, 1, 2, 3, and we need to compare that to the length of the S string. Okay, so the length of S string is 3 and I is at the third index, so these two are equal. So then we return true at the end of our program. Okay, so in any case we find that it is not a sequence. Let's say I have C over here and then this is B. Okay, so when J is at this iteration and I is at the second value, I, so what this does is, so this keeps on going on. Okay, so J goes to B. Okay, as long as like they are not equal, right? So it keeps on going to B, and now it finds that they are equal, so we increment I, and then J goes out of range, so now they are unequal. So now you see that I is at the second index, but the length of the S string is 3. So 3 is not equal to 2 or 2 is not equal to 3. There we just return false. So I hope you get the logic and how to solve this problem, that is subsequence. Let us see how can we solve this by code. Let's initialize the 2 pointers. Let's say I equals 0 and j is equal to 0. So we can just use them within one line within the let statement. So if you want to declare many values and initialize them, so once we do that, we can just run a while loop, just as I told, as long as j is in range with the length of the t string. So let's say j is less than t dot length. Okay, so now we just need to just apply that logic just as I told. So if we have the string at the ith iteration, so if that is equal to the value of string t at j value, then we just increment I, and then we also increment j irrespective of this condition passing or no. Okay, so we just want to always increment j. So we just want to now return after this while loop, as I told, if the value of I is equal to the string dot length. Okay, so if I run this and all of our test cases are passed, so let's see our performance. Okay, so best in time complexity, but this solution is the ideal. So basically we are keeping 2 pointers and we are just comparing elements, and we are not reiterating the entire string again, just as we do in nested while loops. Okay, so this is the solution for the problem is subsequence. Let's see the next problem. So this is a problem called replace all digits with characters. Okay, so we will be given an input string over here just as this, and we just need to convert all of the numeric values that we have into characters. So how do we know like what character do we add over there? So we need to check what is the previous character. So the previous value of this numeric one will always be a character. So we need to check what is that, and we just need to add 1 to it. Okay, so if I add 1 to a, it becomes b, right? So we need to replace this with b. Okay, so just as we have shown over here, so the output is a, b, c, d, e, f. So that's the problem over here. Let's see how can we solve this. So I've just considered this to be a given string. So you see that for every character there is a numeric value which will represent what should be the character relative to the previous value. So the previous value is a, so if I add 1 to a, so that becomes b, right? So I need to replace this 1 with b. And same way, if I convert that to a character by adding 2 to the previous character, so that would become c, d. So I need to replace 2 with d. I hope you get the idea. So how do we solve this? Like what logic do we apply? So let us consider this pair, that is a1. So if I want to calculate the character code of a, so that will become 97, right? So that is according to ASCII, that is the character code 97. So this keeps on going like in a sequence, right? So if I calculate the character code of B, that would become 98, and C is 99, and so on and so forth. So if I want to calculate what is the ASCII of the next value, so that is B, right? So I just need to add 1 to that. So 97 plus 1 becomes 98. Again I need to convert this back to a character, so that would become B. Okay, so we have inbuilt functions in JavaScript where we can convert a number or a character to its numeric value or vice versa. So once I find the character at 98, so the ASCII value of that, so I need to replace this 1 with B. So what we can just do is we can create an empty string. So we can just start replacing. Okay, so we can replace this with B. So again we need to keep doing the same. So what is the character code at B? So that is 98, right? So I'll just erase this. So we have B. So the character ASCII value of B is 98. Okay, so I need to add 2 to it since that's the numeric value after that. So if I add 2, that would become 100. So now what is the character at the ASCII value 100? That is D, right? Put a function to calculate that, I will get D. So I need to add D to this. So A and B are added, so we need to just add B, and whatever the value that we have calculated, that is D. So we need to keep doing the same for all the other elements within the array. Okay, so this is the condition that will always be true. So basically all the odd indexes, so that is 1, 3, 5, 7 will all be numeric values. So we only need to apply that conversion to find the actual value that relative to the previous one. Okay, so I hope you understood this. Let's see how can we solve this inside JavaScript. So let's set the result, so basically the final string to be returned to an empty string like so. And now we can just put a for loop and we can initialize the I value to be 0, and then we set I is less than the string dot length, and then we increment I. So after this we just want to check if the current iteration is a odd value. So if it is an odd value, then it is a numeric one, right? So they have given in the constraint also over here, for all odd indices I, so it is always a numeric value. So we can just check if I %2, if that equals to 1, which means that it is a odd value. So basically we have a numeric value within this block. So I need to get the previous value, which is a character, right? And I need to calculate what is the character code of it. So we can just use the previous value. So we can just say s dot I minus 1, and I can just use the char code at, and I can just specify 0 over here, so which will get the character code at for this value. And here I just want to add the numeric value, so I can just set I. So I need to convert this to a number, so let's wrap this in number. Okay, so now we have the character code, so I need to get the character out of it. So I can just wrap the entire thing into like let's say string. So basically it's a string constructor, and this has various methods like from char code, which will actually get the character for the value that we pass in. So from char code, and we can append that to the result string. Okay, so finally we return the result. Okay, so this is the important line which we need to understand. So first we need to check the previous value, which is a character, get the character code of it, add the numeric value to that, and then convert that back again to a character, and then append it to the result string, and then finally we return that. So let's run this, and of course I forgot to handle the else case. So if that is basically a character itself, so we just append that to the result string. Okay, so now if I run this, and that passes. Okay, so let's see in terms of performance. So we are getting best in time complexity. Okay, so this is the solution for the problem, replace all digit with characters. So that's it for this video, guys. So if you have come till here, I really appreciate you learning DSA through me. I hope this whole series was actually helpful, and to solve all the DSA questions related to strings, and maybe in the future I might come up with more videos like related to those problems that are medium and hard. So yeah, so far I have just covered all the top string problems that are frequently asked within our interviews, and I hope this explanation would help you understand and crack it in a very easy way. And yeah, so that's it from my side, guys. Thank you so much for watching. Make sure to subscribe for more videos, and I'll see you guys in the next video. Bye bye.